Here we go, lecture 10.4, lecture 2 of 2. I gave an inverse trig lecture and general inverse lecture. And basically, if you want to do inverse trig, you need to know this much. The range of sine inverse, cosecant inverse, and tangent inverse lie in the first and the fourth, and these are angles, and they range from negative 90 degrees, negative pi over 2, to 90 degrees, pi over 2. This is a tricky quadrant. So if you think the answer is 300, you better say negative 60. And then the range of cosine inverse, secant inverse, cotangent inverse is in the first and the second, 0 pi. And finally, trig of an angle equals a number, where this is the domain of the trig functions, and this is the range of the trig functions. If you take trig inverse of both sides, theta is trig, that's really quite sloppy, trig inverse of a number. So whenever you're asked an inverse trig question, the answer is always an angle, and that's the range of the inverse trig. Remember, that's also equal to the domain of the trig restricted, which is another word for scribble. So if you remember where you scribbled, then you know all this. And this is the domain of the trig inverse, but easy to remember the range of the trig. So you can only plug numbers into an inverse function such that they're the range of the trig, associated trig function. For example, don't do inverse sine of 3, because the range of sine is between negative 1 and 1. All right, that's what you need to know. Let's do some problems. Arc tangent of 1. That's old school for sine inverse of 1. To do sine inverse, you say, well, the answer must lie in 1 or 4, and I know the answer is an angle. But then you take sine of this and sine of this, meaning sine of the left and sine of the right, you get 1 equals sine theta. And then you're like, I know what sine looks like. I know sine, all students take calculus, is positive in the first and the second. The range of inverse is first and 4, first and second. Therefore, 1 dot high, 2 low, theta is in the first. Here's where it equals 1, right at pi over 2. And it equals a 1 again, of course, later. That's an answer, well, on the boundary of the first quadrant, actually. But that is the answer in this case, from minus pi over 2 to pi over 2. All right, let's try another one. How about inverse secant minus square root of 2 equals some angle. First of all, secant inverse, like cosine inverse, is in the first and the second. My answer in the first or second. Take secant of both sides. Now, you can think now or think after this move that the reciprocal of the right equals the reciprocal of the left, and I've done the reciprocal of the square root of 2 enough to realize that it's the square root of 2 over 2. Secant and cosine are negative in the second and third. Inverse makes sense first and second, therefore theta is in the second. We know that's at 135 because we have the unit circle memorized. If you don't, you should memorize it. Therefore, the answer is 3 pi over 4 because radians are cooler. All right, so they got some questions here for you, and they are a little tricky, so let's get after them. First of all, if I say inverse sine of negative square root of 3 over 2, your calculator will give you the answers, no problem. Make sure you're in degree mode. Always cheat in degrees when you work at inverse problems. And go inverse sine negative the square root of 3. Scoochy. A little slow. Divided by 2. There. You don't need to know anything. Minus 60 degrees, which you know to be minus pi over 3. But what happens when somebody goes inverse cosecant of minus 3? I don't even think that's a unit circle number. You got to be careful when you're doing this. So, you know what I do is I say it equals some angle. And I say I've memorized inverse cosecant, the range of it, where the answer lies. It's the same as sine, so first and fourth. So the answer lies between negative 90 degrees and 90 degrees. So take cosecant of both sides, and I get negative 3 equals cosecant of theta. Then I reciprocate both sides, and I 100% know it's not a unit circle number, which means the only way you can actually get the angle is to inverse sine both sides. And then you crank it out on your calculator, inverse sine of negative 1 divided by 3. And we get negative 19.47122063 degrees. Or you could go mode, radian, second quit, reevaluate, and get negative 0.339 rad. Now, you're thinking, well, why don't I just change the problem right away? Why don't I just reciprocate? And the answer is, on that problem, you could have. But there's another problem that looks exactly the same that causes some pain. So here we go. When somebody gives you arc cotangent of negative 0.3541, which is inverse cotangent of negative 0.3541 equals some angle, and this is some number that better be in the range of cotangent, but the range of cotangent is minus infinity to infinity, so we're good there. some people want to reciprocate. Well, here, let's take cotangent of both sides. Here we go. All right. Now, some people want to reciprocate, but trust me, this is going to get you into a world of hurt, because cotangent inverse is defined in the first and the second. But if you flip it, reciprocate it, tangent inverse lies in the first and the fourth. Therefore, be careful. Here's the secret. I'm the guy that wants to, well, first of all, what quadrant are we in? We all know we're in the second quadrant. Theta's in 2. Because cotangent is negative in the second and the fourth, but cotangent inverse only makes sense in the first and the second, therefore we're in the second. So make sure you end up with an angle in the second. Trust me, if you reciprocate, okay, I gotta go get my calculator. Went to my other screen. Here we go. Whoa. If you reciprocate, and what's the reciprocal key? Negative 0.3541 reciprocate. Negative 2.824061. Theta equals inverse tangent negative 2.824061 of the last answer. And this is not good for me, because I'm not cheating in degrees like I should be. So I'm going to go back and cheat in degrees and reevaluate that. Therefore, theta is negative 70.5009, answers in the fourth. That's not good, because we know the answer is in the second. So my own personal rule of thumb is, if I'm the person who decided to inverse something, I never inverse a negative number. We know what quadrant we're in, so let's just find the reference angle. So I'm going to go inverse tangent of 2.824061. And of course, on my calculator, I'm going to get 70.5009, knowing this is theta ref, the reference angle. We know the answer's in the second, so it's 70 degrees this way. So we go 180 minus the last answer. And we pick theta up to be 200. Whoa. Oh, yeah, my bad. 180 plus, and we get 109.449. Just know that's a classic problem. Everybody struggles with it. It's just kind of crazy. Now, the book has all these specialty problems. They're kind of fun. They're meant for you to learn your identities, which you had in section 10.3. We'll be working on that for the rest of the semester, by the way. So don't think you're actually done with section 10.3. Here we go. Specialty problem. Sine. Inverse. Oops, not really. Sine of tangent inverse of 3/2 equals what? Well, this is an angle. So it's sine of theta equals what? But off the side, tangent inverse 3/2, so tangent both sides. Tangent of tangent inverse is 3/2. Then you draw yourself a little rectangle. Not a rectangle, it would be called a triangle. And you say TOA. Therefore, square root 9 and 4, 13. Sine view, zoom 75. Sine of theta is SOAP. And you look, and that's 3 over radical 13, which is 3 radical 13 over 13. Boom. Game over. Let's work another. Tangent of cosine inverse negative 5/13 equals theta. That would be wrong, because tangent of an angle equals a number, and we know this is an angle. So it's tangent of theta equals, I don't know. But here's what we're going to do. We know theta, cosine inverse, negative 5/13. Now, you've got to be careful here. So, first of all, cosine inverse is in the first and the second. But then when you cosine theta both sides, you got all students take calculus, cosine is negative in the second and the third. Therefore, theta is in the second. But if theta is in the second, you got to go up here and you go, what is tangent in the second? So you go, all students take, so tangent is plus, plus, minus, minus. So therefore, answer is negative. Now, instead of working with the angle, let's work with the reference angle instead. So let's forget about the negative sign. We know cosine's a ka, a 5/13, therefore a 12. And we know tangent, this is theta ref. Theta ref is TOA, 12/5, therefore negative 12/5. The book has their way too, but you're way safer with reference angles. You'll know what quadrant you're in. And the fun just continues, because then they got problems that look really scary. And they use the arc tan, square root of 3 plus arc sine of 1/3. But that's cosine alpha plus beta, where this is alpha, this is beta. Remember, arc just means inverse. So cos alpha plus beta is cos cos, sin sin, alpha beta, beta alpha. And if it's a plus, then there's a minus. And I just need to figure out these 4 things. But off the side, alpha is inverse tangent square root of 3. That inverse tangent only makes sense in quadrant 1 and 4. But it also means tangent alpha is the square root of 3. And when is tangent positive? Well, it's the first and the third. Therefore, we're in the first. And I actually know the angle because I memorized my unit circle, and therefore alpha is 60 degrees. So cosine of 60 is 1/2, and sine of 60 is minus the square root of 3 over 2. And beta is inverse sine of 1/3, not a unit circle number, but sine inverse only makes sense in the first and the fourth. And sine of beta equals 1/3. Sine is positive in the first and the second, therefore we're in the first. So we draw a triangle in the first where this is actually beta, and you say so, you say 1, 3, 9, 1, square root of 8, 2 radical 2. Therefore, when you ask for sine beta, it's 1 over 2 radical 2. And when you ask for cosine beta, whoops, no, sine is 1/3. That was dumb. That was really dumb. You know why? Because it says, whoops, edit undo. It says sine is 1/3. So if I would have said so and went 1/3, you know, we would have been fine. But it's like, hey, sine beta is 1/3. Now let's do cosine beta. Adjacent. So you say ca 2 radical 2 over 3. And then we get to simplify. Hooray for us. So radical 2, these twos cancel, over 3, minus plus, double negative, square root of 3 over 6. Just checking my answer here. Boy, the book sure takes forever about this. It says I'm off by a negative sign. I don't see how. 2 radical 2. Oh. No, I don't see how I'm off by a negative sign. Unless there was no negative on this sine alpha. Oh, there wasn't. So, bummer. This is right back here. This was just negative. Therefore, this is negative. And then they go, you got to find a common denominator. So they go 2 over 2. They go 2 radical 2 minus radical 3 over 6. Yay me. I got it right. These problems can take quite a bit of space. Now, there's another problem. Tangent 2 times arc sine 2/5 is tangent 2. Call this some theta. Then you got to memorize the identity. That's all there is to it. So it's 2 tangent theta over 1 minus tangent squared theta. So what we need to do is a little side work, because we need to figure out tangent. But you're starting to figure out that basically it's inverse sine of 2/5 equals theta, and your answers can only lie in first and second. But then you got sine theta 2/5, and sine theta is positive in the first and the second. And I was wrong. Inverse sine only makes sense in the first and the fourth. So inverse sine only makes sense in the first and the fourth. Sine makes sense in the first and the second. Therefore, we're in the first. Draw a corresponding triangle. You draw it in the first. You say so. 25 minus 4 square root of 21. Tangent is the square root of 21 over 2. That would be 2 over the square root of 21 tangent theta, which is 2 radical 21 over 21. And you need to jam it in up here. I guess when I square it, I'd be better off using this. So the 2's cancel. Get the square root of 21 over 21 over 1 minus 4 over 21, which equals 21 over 21, 17 over 21. So you get the square root of 21 over 17. And the textbook says I'm off by 4. How did I do that? Mm-hmm. 2 radical 21 over 20. Oh, 4. And then, oh, oopsie. These didn't cross off. That was a 4. There's a 4. Done. A little off today, making error after error after error. I don't want to give you the false impression that this stuff is actually, it's actually pretty difficult. So I've been making some simple errors, but at the same time, you got to get, you got to actually see how hard it is. I could have just gave you the straight lecture, but really that's no fun. So I like working these problems. As you can see, they're somewhat challenging. Here's another one. This is really good. This will help you in calculus when you're ready for calculus. If somebody gives you a sine of tangent inverse of u, you got to say that's some theta. And you want to figure out what sine theta equals. So you're going to figure that out. But you got theta is inverse tangent of u. That inverse tangent is only good in the first and the fourth. And then you go tangent theta equals u over 1. Now, the bad thing is, I don't know where I am, because I don't know if u is positive or negative. So I could still be in any of the 4 quadrants. So I'm in the first or the fourth right now. That's what I'm at. So let's just pretend we're in the first. Just draw a triangle. There's some theta. It's u over 1. But you square this, you square that, you square root it. Square root of u squared plus 1. But my question is sine. So it is so. So it's u over. Now sine in the first quadrant is positive. Sine in the second quadrant is negative. So I know this is positive. But let me try it again, but draw it in the fourth quadrant. that means that this point here, so this is the theta, and you say TOA is U1, you know this coordinate is 1, negative U. And this is the square root of 1 plus U squared. So sine theta would be negative U over square root 1 plus U squared. I was reading the solution. It works out pretty good. Just really depending on what U is. If U is negative, it would have ended up negative. So there's two ways to work it. What I did when I worked mine, I said, well, yeah, U could be positive or negative. So when I said this had to be negative U, but if U was negative, it's still the point 1 U. So if U is negative, it's just like -5. It's already down there. So I have an extra negative, and you don't really need it because if U is negative, it's just called U. Therefore, the answer is only one answer, U over the square root of U squared plus 1. That happens a lot in math. You don't know whether to go plus or minus, or just keep it, work it in general. So basically, I chose the wrong path there. I'm the one that didn't read the directions at the beginning of the problem. So it is what it is. But we should probably work on our rationalization skills. So you rationalize, and you get U Doesn't that look lovely? Alrighty. That is literally bare bones, minimal lecture. That's not even me like working some of the homework problems. I'm hoping this actually gets it done. It may be best for me to work some problems in the text. So I know I called it lecture. I got time. It's a 33 minutes. I can squeeze this in. So here we go. I'm looking in the book in section 10.4, and I see some problems that I haven't covered here. So let's give it a shot. So 67 from your book, 10.4, it's sine of sine inverse of 1/2, and we're all thinking it equals 1/2. You know this is some angle theta. So inverse sine only makes sense in the first and the fourth. So if this is theta, we're looking for sine of theta. So sine, you look at this, so you get sine theta. You let theta equal inverse sine 1/2. So sine theta equals 1/2, and sure enough, it equals 1/2. Bottom line, it better equal 1/2. Now, fear this problem. everybody and their mother wants to write 4 pi over 3. And that's why I'm working these extra problems. Recall, sine inverse of a number equals an angle. And the angle must lie in the first or the fourth. But this is 240 degrees. It's in the third. But you do understand that the reference angle is 60, so most likely the answer is going to be negative 60. But you do know sine of 4 pi over 3 is basically the y coordinate. It's like saying sine 60, so minus the square root of 3 over 2. So the real question is, what is inverse sine of negative the square root of 3 over 2? Well, first of all, the answer is in the first or the fourth. And it's an angle. And you take sine of both sides. I know the answers are 240 and 300. So you're thinking about yelling out 300 for your answer because you had to be in the first or the fourth, but this runs from negative 90 to 90. Therefore, you have to go with the negative 60, i.e. the negative pi over 3. Ouch. That thing hurts. So, the bad problems are these problems. And the inverse is on the out. Because you're thinking the answer should be negative pi over 6. Is it? I don't know. I have to work the problem. But I do know this value. That's cosine of negative 30 degrees. So the real problem is cosine of negative 30. You're here, cosine is positive, and cosine of 30 is root 3 over 2. And we know that's some angle, and you take cosine of both sides. When does cosine theta equal root 3 over 2? And you're like, well, that's when it's 30. So 30 degrees or 330 degrees. But we got to be in the first quadrant. Let me see. Yeah, because cosine inverse initially only makes sense in the first and the second. First and the second. And I got answers in the first and the fourth. Therefore, we're in the first. So the answer is 30 or pi over 6, meaning that's wrong. Wow. These are no fun. Problem 87. Approaching the 38-minute mark here. Sine of 2 inverse cos 1/5 sine of 2 theta. And sine of 2 theta is 2 sine theta cosine theta, which equals 2. Figure those out. But this is theta. So theta is inverse cos 1/5. Theta can lie in the first or the second. But cosine theta is 1/5, and cosine is positive in the first and the fourth. Therefore, we're in the first. And draw your triangle. 25, 1, square root of 24, which is 2 radical 6. We know cosine theta is 1/5, we know sine theta is 2 radical 6 over 5. So 4 radical 6 over 25. Boom. Let's try one of those problems in general. Problem 111. Secant, inverse cotangent, square root 4 minus u squared over u is sum theta. So we're trying to answer the problem secant theta. We'll fill this box in a little bit. We know theta is inverse cotangent, square root of 4 minus u squared over u. That inverse cotangent gives you answers in the first and the second. But we take cotangent of theta, and we get this. So basically, you could be in the first or the second. Let's just pretend we're in the first. We did that last time. And you draw yourself an angle, and you say cotangent. And you go, so ka toa. So you go ka o, adjacent over opposite. So square root of 4 minus u squared u square the u, square the square root, square root. This is 2. Now let's answer the question. Secant of a triangle, secant's like cos, so you say sha, hypotenuse over adjacent, 2 over square root of 4 minus u squared. And then we can rationalize, so 2 square root 4 minus u squared over 4 minus u squared. I think we're good. 2 minutes and 20 seconds over. Definitely not my prettiest lecture, but still effective. I did quite a few problems out of the book, so that should hopefully save you a little bit of time. But it's important that you get this section and you memorize where we scribble, because that's kind of the secret to this game. All right, that's the end of section 10.4.